This is House Planning Help episode 338. Hello, I'm Ben Adam Smith, and this is the podcast for you if you're interested in self-build or retrofit. I'm exploring what houses we should be building in the 21st century and trying to break down the major roadblocks that may get in our way. Coming up in this session, my guest is Luke Smith from Build Test Solutions, and we're exploring how you go about measuring and monitoring a home. Firstly, though, a big thank you, and this is to Lucy Cowell, who's been my assistant here for quite a few years, and she's gradually been sucked into the world of teaching, but I think finally it's all in on that. So good luck, Lucy. I know you're going to be fabulous, but I'm certainly going to miss you here. And I was thinking about this, that it was originally a recommendation from Elron Burrell, and a good one at that, Elron. If it never works out in the world of architecture, which I know it already has worked out very well, recruitment is there waiting for you, because that was good. So that leads me, secondly, on to searching for someone to help me behind the scenes in a similar way, or perhaps something different. I'm always interested to see who's out there. I feel anyone who is engaged with what we do here, you're listening to the podcast, you probably have a much better idea of the passion that I follow. We're trying to get the message across of building better homes. And maybe you have a superpower that I could use. Well, that'd be very handy. Maybe you're a media professional that's very keen in environmental matters. Maybe you're a teacher. You're someone who has created digital courses before. It's always interesting to have these chats. When I put these calls out, I've done it on the podcast before, it always leads to something interesting. So get in touch. We've got our contact pages at houseplanninghelp.com. Let's get to our featured interview with Luke Smith, Managing Director of Build Test Solutions. We're going to find out why measuring the building fabric is probably where the smart money goes, and why you have to be careful that you don't get carried away with ongoing monitoring. I started by asking Luke to tell me a little bit about his background.
Yeah, so trained as an architectural technologist at UCLan University up in Preston. From there, first line of work was in the social housing sector, so looking with a number of social housing providers as a consortium at the whole topic of energy efficient retrofit of their homes. Soon after that, I did a short stint with the University of Salford, which is where I caught the bug of measuring and understanding the as-built performance of properties. From there, went back into the world of consultancy, but found myself more and more involved in, again, that matter of how do we measure and understand the real world performance of homes, again, working with quite a lot of universities. And then the business Build Test Solutions was born off the back of that, where it was apparent to me that there was a lot of really good work going on in terms of measuring and understanding buildings, but it was being led by universities, and we were spending £10,000, £15,000 or more forensically evaluating an individual property. So all super interesting, but not at all scalable. So you would get these insights from these one-off studies into these small numbers of buildings, but what can you do with that other than it informs someone's PhD or something? It's not something that's accessible to the masses. So, yeah, Build Test Solutions exists as a company today to try and make building performance measurement and monitoring more accessible and affordable to the mainstream industry. So you don't need a master's or a PhD to do these tests and these experiments. You should be able to try and normalize measurement and make it more commonplace.
And what different elements can we measure? Is there a finite amount, or could you just keep on going with things?
Yeah, there's definitely a balance to be struck, isn't there? We're not saying just because you can measure it, you should. It's today's world of low-cost sensors and things, you can absolutely be at risk of going too far. So yeah, we're definitely strong advocates of measurement for a purpose, measurement for a reason. A lot of the work we focus on is looking specifically at measuring the building fabric performance. If you think about your own home or a property that you're going to be built, you've got the building fabric itself, the bricks and mortar, the insulation, the roof, the floors, those key fabric components. You've then got the building services within the fabric that service the building, the ventilation, the heating system, the hot water provision. And then you've got the occupants within the building, and they're going to inhabit the building in different weird and wonderful ways. And then the environment that building sits within. And so when you break it down like that, it's, like I say, we focus particularly on trying to measure and understand the building fabric. So there we're measuring things like the whole building heat loss rate, what's known as a heat transfer coefficient, measuring the air tightness of the building fabric, measuring the U values of walls, floors, roofs, the key components. I would stress that they are the most important aspects. The building's going to stand for 50 to 100 years, or if not more. Get those fundamentals right, and actually the building services should operate more efficiently. And the occupants, frankly, should be able to live in and use their homes as they see fit, whether it's deciding to use 18 degree temperature set point or 22. That shouldn't really matter if the fabric has been built and performs as intended to a good standard. So I personally think you can easily get too carried away with trying to monitor lots of internal condition factors and internal sort of environmental aspects, measuring window opening behaviours and all of that kind of stuff. I don't know really if it adds that much value beyond just knowing that you've got a fundamentally good performing building fabric.
Is it worth then spending a bit of time on those ones that you've mentioned? They do crop up on our podcast from time to time. Is there a hierarchy? Would you like to do one first?
First thing I think where we should start is that it's worth being mindful of this distinction between the idea of modelling, measurement and monitoring, the 3 M's. So modelling is always going to be a key starting point in the journey of any retrofit or new build, particularly a new build. There's nothing yet built, so you've got to start somewhere. So you'll be predicting parameters or using material libraries, estimates of how the building might perform, and the outputs of that model are only ever going to be as strong as the quality of the inputs. You've then got measurement, so measuring the as-built performance of the building, or in the case of a retrofit, measuring the current performance of the home before you embark on any upgrades, and then measuring again perhaps post-upgrades or investment in insulation. And then once occupied, you're into the realms of ongoing monitoring. And how all those things interlink is that essentially, yes, you would always start with a model. It's not actually particularly commonplace for buildings to be measured, in truth. And that's something certainly we're trying to change here at Build Test Solutions. But building regulations are requiring an air tightness test. They do require that you measure and commission ventilation systems. But what we'd certainly advocate is that you go further in measuring the thermal performance of the building, measuring perhaps some of the in situ U values to make sure that the insulation that's been installed is doing the intended job. And what you can then do is use those measurements to plug back into your model and help calibrate the model to give you a much better reference point, if you like, for how the building should be performing. So then you are starting to appreciate, based on the physical measured characteristics of the home, this is how I might expect it to perform. And then when you're living in the property with all these monitoring aspects going on, you're monitoring the energy consumption, monitoring the internal conditions, you can start to more readily relate that back to the model and appreciate, actually, the calibrated model suggests my energy consumption should be much less than it is, or I'm really struggling to maintain these particular internal temperature conditions. And so all those things combined is helping you to much more readily narrow down where the issue might lie, what the remedy would be. Is it to do with the way that I'm living in the home, the occupancy, the temperature that I'm heating it to, or not, as the case may be, or rogue teenagers consuming excessive amounts of energy in the property? Or is it something fundamentally wrong with the building fabric or fundamentally wrong with the building services?
Let's look at some of those tests of the fabric. And they may just be traditional ways, but I think you've been developing your own approaches. So what do you do, first of all, for air tightness?
So to measure air tightness, the traditional incumbent method, if you like, is known as a blower door fan. So a doorway mounted fan poked through an elasticated hole in a canvas in the doorway. What we've developed at Build Test Solutions is a compressed air-based technique known as Pulse. So how this works is it's an air canister that you place centrally on the ground floor of a building, make sure all the internal doors are open. The tester presses go on the device, and quite simply it releases a burst of air. The instrument measures the pressure response, so how quickly does the background pressure in the building elevate and then recover back down to the original ambient conditions. And so it's a very quick, non-invasive method of measuring the air leakage rate. And crucially, what we're measuring the air leakage rate directly at low pressure. You're not exerting really high push and pull forces on the building fabric. You're measuring air leakage directly at 4 pascals.
I've always wondered that when it's come round to you've got an older passive house and then you do another test on it, whether you're going to come out with not a damaged building, but yeah, you are putting pressure on it, aren't you? You're going to find the weak spot.
Yeah, it's not unusual to see quite large differences between when you pressurize a building or depressurize it, whether you're pushing or pulling on those tapes and membranes and joints and pulling down on the loft hatch, pushing out on the window seals. You are flexing the building envelope in some way, and you're going to get a different response depending on the robustness of those key details and the age of them.
Let's move on to the thermal aspects now. How do you test that?
This is actually where I'd encourage people to start, is measuring what's known as the heat transfer coefficient, so the overall thermal performance of the building. It's not going to tell you specifically where the heat loss is going, but it's a really good barometer of the overall efficacy of the building fabric. So how well does it retain heat? There are a number of different ways you can go about doing this. I know, Ben, you had Tom Fenton from Veritherm on a previous podcast. So they've got a fantastic overnight test method, sunset to sunrise, heat up and cool down cycle that's able to then present you with this heat transfer coefficient number. We ourselves at Build Test Solutions have developed an alternative technique called Smart HTC, and this is more of an in-use method, if you like. So the property can continue to be lived in and used as normal, and with 3 weeks worth of internal temperature data combined with the total energy consumption for the same period, we're able to run that through our algorithm to return the same measurement, essentially, the heat transfer coefficient, the thermal performance of the building. So it enables you to perhaps measure early on within the defect period of a new build home, perhaps, or in your home that you're thinking about retrofitting or thinking about installing a heat pump in. And then you can very readily measure again post-works or a year or two down the line with no disruption to your day-to-day life.
And there was one more, wasn't there?
Yeah, the third method would be, it almost becomes a bit of a triage approach where you can imagine you'd something like Smart HTC or Veritherm to measure the whole building heat loss rate. Typically, a third of heat loss is attributable to air leakage, so then that's where a blower door or a pulse test would come in. So of that total building heat loss, what proportion is attributable to air leakage? And then the third method we've got is a technique we call Heat 3D, which is used for measuring the in situ U values of a building. So what specifically is the rate of heat loss through an individual wall, the floor, or the roof. So you're drilling down to a component level, trying to understand the specific component of a building. You'd only really be doing that if you're in this triage process. The whole building heat loss measurement, for example, has highlighted that you've got an issue. So this is you drilling down into, okay, you know you've got an issue, so that you're chasing it now. So is it specifically my walls? Is it specifically the floor or the roof? An issue with the windows.
And does this happen before the occupant even steps in almost? Is that the idea of it? Before we have extensive monitoring, we're thinking, have we finished here?
That's naturally a good time to be doing it, isn't it? Before you've moved all your furnishings in and you're trying to live in the property and get on with your lives. But that's not to say that's the only time for it. These measurement techniques, they aren't in themselves all that disruptive. So you can absolutely measure the thermal performance of lived-in occupied homes, the air tightness of occupied homes, the U values within occupied homes. So, yeah, it depends what we're talking about, whether it's a new build home that you've just built, and of course you're going to have the luxury of doing some of these tests before you move in. But if you're talking about an existing property that you're thinking about retrofitting, or you've inherited a relatively new build home, there's nothing stopping you doing some of these measurements and checks at any point in the building life cycle.
I suppose what I'm getting at really is, are we expecting it to change? I'm just assuming, we built our place, that's it. It's going to be like this forever.
You'd like to think that once you've done those measurements and verified that the building's performing as intended, you're not going to be all that susceptible to too much change. There'll be a bit of seasonal variation, so if the walls are wet, or a little bit of sort of settlement and that kind of thing might marginally affect the performance. The only time you're going to perhaps see real sort of trailing off of the performance, if you like, would be if you've got a serious defect. So let's say, for example, a property has had blocked gutters or blocked downpipe for a long period of time that's now saturated the wall and started penetrating through to the insulation, which once wet is going to take a long time to dry out, and when wet isn't going to perform anything like it should. So it's going to help you identify any serious defects with the building if done down the line.
So you mentioned right at the beginning about how cost was prohibitive for a long time. Is anyone actually just taking advantage of all of this and doing frequent tests?
Yeah, we're seeing a lot of variation in how these different tests are being adopted, if I'm being honest. So it's not necessarily that these measurements are only suitable for the big projects where you're building a whole new house or doing a deep renovation. Some of the adopters of these measurement methods include heating engineers and energy assessors, who are offering it as quite a nice add-on service to things that they're doing already around doing heat loss calculations and recommendations for even single measure upgrades, like just a heat pump or modest changes to a property, and doing the measurements before and after. Lots of interest, as you might imagine, in the social housing sector. So looking at, again, how you baseline properties and understand and help prioritize the investment, and then again go back and check afterwards. So yeah, a really broad church in terms of the level of adoption and the regularity of it. If you imagine something like Smart HTC that I described earlier, around measuring the whole building heat loss rate very simply with 3 weeks worth of temperature and humidity data, our algorithm, our charge is £10 per building on the system. So we're not talking break the bank type of money to just spin that algorithm once a year on your own home to check that the fabric performance is all in order.
Can you take us through an example then of how we might use you as a company? What does it look like? So
Build Test Solutions, we exist to discover, develop, manufacture measurement tools and techniques. So the 3 M's, we place particular emphasis on the measurement side of things. We're developing different tools for measuring heat transfer coefficient, U values, air tightness. And our model is actually more of one of business to business. So our mantra is empowering others to act. So we're selling typically to building surveyors, energy assessors, consultants, who in turn are then able to offer measurement services to individual householders. So on our website, yes, you can absolutely buy the equipment outright, but also there are directories where you can find a local provider of these measurement and test services.
And as a homeowner then, let's say I'm starting to explore, what's the CO2 level? Does it build up a lot in here? What's the humidity of the room and so forth? How do we do that? Do we do that with one piece of technology, lots of pieces? Do we get in a company to do it, like some of these people you're selling to?
Yeah, so the ongoing monitoring piece is a really interesting and dynamic space. So I think, once you're perhaps happy with the physical performance of your building, or you feel that actually you've got little in the way of control over changing anything with the building fabric, if it's just about that ongoing monitoring piece, we're talking here about monitoring the energy consumption. So whether that's just total energy consumption at the meter or perhaps a sub-circuit level, sort of what's going on in terms of total consumption for my lighting or my cooking or the consumption of the ventilation system and so on. A really big proportion then is monitoring perhaps of the internal conditions. So you touch there on relative humidity, maybe CO2 levels, ambient temperature conditions. You can get into lots of more in-depth indoor air quality factors, so monitoring certain particulates, VOCs, radon, carbon monoxide. Then you're tipping into kind of a health space almost, sort of what's the quality of air in my home that I'm breathing. Perhaps you've got members of the household that have respiratory illnesses or young children that you're keen to protect, and that's where that ongoing monitoring piece comes in. In terms of the technologies available, you could categorize things in a number of ways. One category might be that you've got, for instance, what you might define as portable sensors. So you can absolutely go out there today and buy either battery-powered or plug-in mains-powered devices that will do relative humidity, CO2, particulates, internal ambient temperature. That's a portable device that you can choose to locate perhaps centrally in the home as a one-off location. You could readily rotate it around the home and check different rooms over different periods. Have a few of these portable devices dotted around. In addition to that, you've separately perhaps got smart meters, and so you're quite quickly starting to, across a few different devices perhaps, paint a picture of both the energy consumption and the indoor air quality of your home. And then thinking beyond maybe portable devices, you would have a semi-permanent installation. So there are monitoring platform companies out there that will offer essentially this idea of you have a gateway or a central hub from which you can connect multiple nodes. So you could perhaps distribute multiple sensors across a home, CO2 sensor, temperature, humidity, carbon monoxide, all of these things that talk to a central hub that can in turn present it all back to you on a single dashboard perhaps. And then maybe the third category would be like a permanent installation. So there are absolutely companies out there that offer hardwired systems that can be hugely complex in terms of able to offer both the audio-visual experience in the home, the whole security platform, and it's not unusual for them to have a kind of an energy management layer as well. But yeah, for portable systems, say you're maybe at the £100 to £200 mark, whereas a permanent type installation like that, you could easily be into the thousands of pounds.
This is a smart system.
Essentially, yes. Yeah. So yeah, you would go from portable devices, perhaps just giving you that data, but in a very flat kind of way. You would have to look at that and interpret it for yourselves, whereas a permanent installation might be a smart energy management system or a home energy management platform that's maybe able to track internal humidity conditions and then trigger your ventilation to boost, for example, or trigger your windows to open. But that's where you're into the thousands of pounds, because you're now linking these things up and into the realms of automation.
It's making me think a little bit about why am I doing this? Because I do monitor certain aspects without logging it. That's the one thing that I would have liked to have done. I've no idea, perhaps as you've alluded to, how useful that will be. But I quite like to know what the temperature is in the house. I don't know why. Why do I like to do that? And then the humidity is also useful to see that you're in that 40 to 60% range. But is this what you're getting at, that really I start logging all these things and it's really only to go to a building conference?
No, you're. I've been there myself. I do exactly the same. I track CO2, humidity, temperature in my own home, and that's what I mean. I speak from experience that it's interesting, but how often do you actually look at it? What actions do you take off the back of it? And that's where I guess we come back to this idea of measurement for a purpose or monitoring for a purpose. Back to the measurement thing is, with energy data and internal temperature data combined, you're able to then determine things like the rate of heat loss from the building, so how efficient is the building fabric. Whereas if you've just got temperature data on its own, yeah, it's maybe reassuring to yourself to say, I've tracked a good average temperature over the course of the year, or I can demonstrate that I've maintained stable internal conditions. But you have to be pretty well engaged to be looking at that regularly and perhaps adjusting your thermostat or using that data to take action on it.
Let's take the example of temperature, and in my house, I have to make sure that in summer months, for example, that I'm night cooling. Is there an argument to say that I should just be forgetting about looking at the temperature and actually just feeling it a bit more? Or I would imagine I'd go into more problems that way. Or maybe just looking at the weather forecast. I don't know what would be more helpful.
Clearly, if you're engaged in this stuff, you're looking at the temperature data. That's informing your decision to purge ventilate your home or to press the boost button on your ventilation. I think where the world's ultimately heading in this whole world of Internet of Things, sensors and nodes and smart home speakers and smart home hubs that links all this stuff together, it's all in this pursuit of trying to help a homeowner automate a lot of that stuff. For me personally, I just think the novelty of having the data can wear off, and are you really using it for a meaningful purpose?
So what else is important in this arena then?
Probably the most pertinent thing about this whole subject matter is the health benefits and understanding key aspects of indoor air quality that, if not tracked and not acted upon, could be detrimental to your health. So that's where maybe things like tracking CO2 levels with quite visual alerts perhaps. So there are devices that will give you nice simple red, amber, green warnings on certain levels of CO2. Similarly, you touched on tracking relative humidity. Of course, naturally, you do not want to see your property consistently tracking at 80+% relative humidity at all times. So those kind of things that can give you really meaningful red flags, warnings to fundamentally act and change your behaviours or change how the ventilation's working or not, as the case may be, I think is where maybe the sort of the nub of this comes to.
Because you're always otherwise left wondering, how good is the air quality? Because we can't tell a lot of these things, can we, just by thinking, is this air quality good? Which I suppose is counterintuitive.
Yeah, and especially as we pursue building ever more airtight homes in the interest of energy efficiency, which is absolutely the right thing to do. But as we push on with airtightness, we become ever dependent on the effectiveness of the mechanical ventilation system that we install alongside. And so if filters are clogging up or the system isn't balanced correctly and extracting as it was designed to do, then you are in quite a risky territory where that ongoing monitoring of key aspects of indoor air quality is important. It might be that, for example, you're also next to a busy road, and so being able to again see alerts on the idea of external pollutants coming into the home or certain soft furnishings off-gassing and polluting the indoor air, that is all naturally very pertinent to our health and well-being and well worth understanding.
Let's put you on the spot then. So what do you monitor of your own home and why, and where is that data?
Very good question.
I'm assuming there is data.
There is, streams of it. I personally monitor just relative humidity, internal temperature and CO2. CO2 just in one location in the home.
Would it vary a lot throughout the house?
CO2 is going to build up in spaces that you regularly populate. So if there's lots of you sat in the living room, you might expect to see CO2 spike, or perhaps two of you in a bedroom overnight, door closed. Again, you might expect CO2 to be problematic.
And one of the key things that you did mention was that energy usage. Now that is useful because there's normally a cost attached to that. So is the best way just from the bills that you're paying, or what else do we need to consider?
Yeah, it's quite frightening how we have been used to typically just relying on our direct debit deemed consumption. I do think the advent of smart meters are really changing that. So if you haven't already got a smart meter, I'd strongly advocate that you take up the offer from your energy supplier to have one of those installed. And then with a smart meter, that is instantly able to give you 30-minute interval gas and electric consumption data. For most people, that will be more than enough to be able to see day-by-day consumption. If you did want to go further than that, there are what's known as a CAD device, a consumer access device. That could be in the form of an in-home display or a small little hub that can help you unlock even higher frequency data from the smart meter. It would still be 30-minute interval gas, but you can in fact get as granular as 10-second interval electric through a smart meter. That can be particularly powerful and useful, especially when you're into the world of perhaps you've got solar panels generating during the day, you've got an electric vehicle discharging through the night. Those kind of things are so much easier to see and track and understand what's going on when you've got higher frequency electricity consumption data. Where it gets more complicated is if you want to then try and understand your electricity consumption at a sub-circuit level. So what specifically is being consumed by my lighting, or specifically at the electric car charger, or specifically by the heat pump. Whilst you can get clamps and circuit breakers that allow those sub-circuits to be directly monitored, where the world's heading now is, all of your EV charger is likely to already be smart and with an integrated metering capability. Heat pumps typically give you both the electricity they've consumed as well as the heat output that they've delivered within the interface of the device itself. Things like smart light bulbs and things like that will come with a hub that will track, again, what those lights have consumed in energy terms. So actually, without any additional proprietary clamps and breakers and monitoring equipment, you're able to unlock quite a detailed level of insight into what's going on in the home from an energy consumption standpoint.
Do you have any other tips then coming to mind that might be useful in that just starting out monitoring the home?
I think my top tip, if you like, would be to look at these platforms that are coming on stream today that embed what's known as the Matter protocol. So this is a universal communications protocol that more and more devices are adopting that allow tech within the home, Internet of Things devices, to all talk to one another and interface together. So if you, for example, have adopted a Matter-enabled smart thermostat and a Matter-enabled smart home speaker and Matter-enabled EV charger, for example, all of those things will be able to talk to one another and present you information at a central point. I strongly encourage people not to get too carried away with trying to monitor everything and anything. Really try and appreciate what it is you think you want to understand and subsequently control, or what have you got power to then take action on yourself. So if it is things like wanting to understand the indoor air quality and subsequently then use that information to determine when you open windows or boost the ventilation, then absolutely a few sensors dotted around the home that are tracking things like CO2, relative humidity, perhaps a certain level of VOCs, so you've got an idea of the general level of pollutants in the air. That can all be very handy indeed.
Sensors, you've mentioned a couple of times. What does this physically look like? Where does it go in a room? Is it something that's just hidden almost?
Again, there's such a wide range of things out there. When I describe the portable sensors, these look like almost matchbox-size devices.
That's what I've got.
Yeah, some of those, they'll have 2 or 3 AA batteries in the back of them. Some will just plug into the wall. And so they'll sit on your bedside cabinet on a shelf somewhere, quite discreet, out of the way, quite happily. You can get devices that almost look like smoke alarms. So again, battery operated, doesn't need to be hardwired at all. And ceiling mounted indoor air quality sensors also exist. If you're into the more semi-permanent, permanent installations, those can almost be invisible, sort of embedded within the fabric, fixed within lighting switch plates, because they've been designed in from the outset or well considered as a whole house monitoring management platform. By their very nature, they can be better hidden and integrated into the fabric.
So let's just start to wrap things up, and it feels like it's going to make more sense to almost come back to where we were at the beginning, where you were trying to stop me from going on to all the little gadgets and so forth. So for a typical homeowner, what post-occupancy tests do we do, or perhaps should we do? Sometimes we take it for granted, don't we, that we've modelled it in the beginning and we want it to be like this, but we then think, oh, that's a lot of money to fork out now.
Naturally, if you're embarking on a new build home, a deep retrofit of your property, it would not be at all unusual to be starting out with a model, a prediction of the performance of your home in some way. But if I was spending myself maybe tens of thousands of pounds on lots of insulation and a deep renovation of my property, or into the hundreds of thousands of pounds in building my own home, the main thing that's massively overlooked is the role of measurement and testing at effectively the point of handover, if you like, after works have completed, to verify that the design intent has been delivered upon. And I think that is so critical. Building control aren't looking for that on your behalf. They're just chasing the paperwork and the sign-off based on visual inspection. In your interest, having spent thousands of pounds, you should absolutely be wanting to measure and check that the building, as it stands in terms of its physical properties, the built thermal performance, the built airtightness, is as it should be. Because if it's not, you're really chasing your tail then in terms of, for example, you've got high relative humidity, you've got high CO2 in your home. It will be able to be traced back to those fundamentals of, well, you've got the ventilation not performing as it should be, the flow rates aren't delivering what the commissioning certificate said they should be, or this kind of thing. So that measuring at a point in time, and it might even be that you built your own home 5 years ago, but to do a point in time measurement check is invaluable.
Finally, just our conversation today, if we're going to have one final thought, what should we take away as a key message?
The very useful adage of what you don't measure, you can't manage. So until we start recognizing that models have their limitations and are actually not all that helpful to us until we start measuring and checking the real world performance and using those parameters to calibrate those models and essentially embrace the Internet of Things movement, low-cost sensors, to recognize the importance of having a home and an internal environment that performs as it should be and meets our needs and provides a healthy, comfortable place to live.
Lou, thank you very much.
Thank you.
Head online to take a look at the show notes that accompany this session, houseplanninghelp.com/338. You can review the key points in our summary, get some visuals on the measuring devices that we've been chatting about and the monitoring equipment. Perhaps you've got a comment or you'd like to ask a question. You can do that within the show notes. Just head down to the bottom or on social media. We'll give you links, and links, of course, to Build Test Solutions. houseplanninghelp.com/338. And we'll finish up today with a hub update. This is the membership community that I run alongside House Planning Help, where you can interact with like-minded people, all at various stages of their low energy projects. We've just had another Ask the Expert session. So Ez Trezida has been on hand to field any questions around building physics, moisture, all sorts of things. So we talked quite a bit about heating actually on this one. Air-to-air heat pumps. I discovered that the cost of that can be significantly lower, but there are obviously factors that you have to take into account. We also talked about infrared heating systems, insulating stone walls, all sorts of things, and it's a regular fixture now, so we'll be doing it again soon. We've got all of our other bits and pieces, the in-depth video case studies, which will take you through entire projects, just trying to explain some of the decisions that are being made along the way. So you get a feel for things, and the courses try to map out different aspects of the process. We've got our forum as well, where you can interact with your fellow self-builders and retrofitters. And if you want to chat with me, then I run Office Hour every week, so you'll have a chance to chat through whatever is on your mind. Investigate further, houseplanninghelp.com/join. Next time, Mark Brinkley, author of the House Builder's Bible, returns to the podcast. It's quite a wide-ranging episode. We reflect on his project 5 years on, similarly to the podcast that I did about my own build. We talk about cost. How do you keep it down? It's expensive to build these days. And just the whole self-build process. Thank you so much for listening. The House Planning Help podcast is produced by Regen Media, content that matters.